All right, let's take a look at some problem-solving questions that allow us to model periodic situations with trigonometric functions. So let's take a look at example 1. Example 1 says, and if you check out your handout, to test the resistance of a new product. I'm probably gonna try to make this available on the description of the video too. To test the resistance of a new product to temperature changes, the product is placed in a controlled environment. The temperature in this environment, as a function of time, can be described as a sine function. The maximum temperature is 120 Celsius, the minimum temperature is -60 Celsius, and the temperature at T equals 0 is 30 Celsius. It takes 12 hours for the temperature to change from the maximum to the minimum. If the temperature is initially increasing, what is the equation of the sine function that describes the temperature in this environment? Okay, so this example already tells us that it's going to be a sine function. They also tell us what the maximum temperature and the minimum temperature is. And they tell us that the temperature at time 0, which will be in hours, T will be in hours, the temperature that it starts at is at 30 Celsius. Okay, so well, let's collect our data first, okay? So what is very obvious here, let's start collecting the maximum temperature. So the maximum temperature happens to be 120 Celsius. The minimum temperature, it's -60 Celsius. They also tell us this, that at time equals 0 hours minus, well, the temperature would be 30 Celsius. Okay, and they tell us something else. This is very key. It says that it takes 12 hours for the temperature to change from the maximum to the minimum. Okay, so this is basically, they're giving us information about the period. Now, if you go from the maximum temperature to the minimum temperature, and it takes you 12 hours, you know, it's always good to have a sketch. So they tell us this is, you know, the maximum temperature, this is the minimum temperature. It takes, according to this, it takes to go from there, from the maximum hour to there, to the minimum hour, it takes 12 hours. Now, is this the period? No, because the period is one complete cycle, or this looks more like a half a period. So if it took 12 hours to go from the maximum to the minimum, it will take another 12 hours to go from the minimum back to the maximum. So in total, we can say that the period will be equals to 24 hours. Now, right now, we're just collecting data, right? They told us to use a sine function. We could use a cosine function, but we're using a sine function because that's what they say, and it's probably the easiest way to figure this out, to figure the appropriate function for this. So we know that the period is 12 hours. Okay. So if we're going to use a sine function, we might as well do this as a base. A couple of things. So the base function for this will be y equals sine, let's call it sine x, which would look like this. So always have this as a reference. Make sure you know how to do these. So you start from 0, you go up to the maximum, then to the minimum, and it takes, in this case, we're using radians, so it takes 2 pi to complete one cycle, right, one period. That will be pi halfway in between. This would be pi over 2, and this would be 3 pi over 2. Okay. Alright, so this is our sine function. Now also they're asking us to use sine, so we're gonna have to model it after this function. Oh, sorry, didn't notice that we needed more space. So y equals a sine, open bracket, k x minus d, close bracket, close square bracket, plus c. So our goal is to collect all of this information, a, k, d, and c, so that we can have a proper sine function that models this situation in example 1. Okay, so let's start collecting this data. Right, we know that the amplitude will be this value, the value of A. This up. The amplitude will be the value of A. So this is our amplitude, and the amplitude, the formula of the amplitude, check your notes if you don't remember it, but it's the maximum minus the minimum value divided by 2. So what's our maximum value? Our maximum value is 120 Celsius minus the minimum value, which happens to be minus 60 Celsius, divided by 2. So what happens here? This becomes a plus 120 plus 60 is 180 divided by 2 gives us 90 Celsius, or 90 degrees. So that's our amplitude. And we also need the equation of axis, EOA, the equation of axis, and that's, how do we get that? The maximum plus the minimum, so the maximum plus the minimum value divided by 2. So now what is our equation of axes? Well, the equation of axes in this case, it would indicate that this becomes a minus, so 120 minus 60 gives us 60 divided by 2, that's 30 Celsius degrees. Also, we need to collect, we need to find out what K is going to be. So far we have A, we have C, we need to find out what K is. We need to find out what K is. So K is, what is K? What is K? Where's, oh yeah, K. So how do we find out K? Well, we know this. We know that the period is equal to 2 pi over K. So if we already have the period, we can solve for K. So our answer, oh, sorry, I didn't know it was off the screen again. I apologize. Okay, so hopefully you got that. We also know that the period, as I said before, is equal to 2 pi over K. So let's solve for K. Well, let's substitute the period and solve for K. So the period happens to be 24 hours equals to 2 pi over K. How do we, okay, so 2 pi over K, let's move this up again. And let's solve for K here. So K will be equal to 2 pi over 24, which gives us, which is the same as saying, so half of this is 1, half of this is 12, which is the same as saying pi over 12. Okay, so I think we've got everything. Now one last thing is this part of the equation, which is D. So they tell us that at T equals 0, the temperature is 30 Celsius. Well, and that happens to match this. So at T equals 0, we start there. So essentially we're starting at the equation of axes, which, if you look at the base function, that's where we start as well, right? This is the beginning of our sinusoidal wave. So in other words, even though they're not asking in this example to graph it, I will provide a graph. I think that will be very useful. In fact, let's collect. So now with the equation, we can do this. So y equals to, what's the value of A? So we can say it's 90 sine, open the square bracket, the value of K is pi over 12. Okay, now I would have put X, I know that's what I started with, but they're using T, so let's do that as well. T, small t, so instead of X we're going to use T. There's no phase shift since we start at the origin of the sinusoidal wave, and plus the equation of axis, which happens to be 30 Celsius. So plus 30. This is our equation. There's no phase shift. So that's the answer. There's no phase shift, and on the next video we'll sketch this, even though they didn't ask for this. So this is a sinusoidal wave, a sine function, as they requested, a sine function that describes the temperature in this environment. Okay, I guess if you can say, you know, y represents temperature. Maybe I should have said this at the beginning, but temperature, and small t represents time in hours.